Hello, eSchool Gates. Welcome to eSchool platform. I'm called Remy, your maths teacher. Today's lessons we shall have will be on integrations. Calculus 1, where we will see how to solve integration using the by-part formula. So let's kick off. For our first concept, defining by-part integration, which is as a result to the product of two functions. So here we can say if you are given y equals to uv, where u and v are two functions which depends on x. So we can have a change in uv with respect to dx from the prerequisites of differentiation. Product formula, we have u dv dx plus v du dx, as you can see. Then by basic algebra, our change in uv will be u dv dx plus v du dx times a common dx, that's cross multiplication. So again, we can have uv equals to u dv dx times our dx plus v du dx times a dx, as you can see on the board. Then we should remind ourselves that integration is distributive and is well defined over the operation plus. So if we share the integral on both sides, we have the integral of u dv dx times dx plus the integral of v du dx a times a dx. So as a result, we are going to have a uv integrating 1 with respect to uv, generate uv, since uv is the only parameter accepted by the integral. So we are going to have equals to u dv dx times a dx plus the integral of v du dx times a dx. So finally, as subject of the formula, u dv dx times dx is equals to uv minus the integral of v du dx times our dx. This gives us our by-part formula to be used in our application. So as an example, we have on the board says uh, we should integrate x e to the x dx, as you can see on the board. Let me see example 1. So here, to carry out our integral here, we will start first by letting our u to be x. It means that our du dx will be 1, and then our dv dx is e to the x, as you can see. So this implies our dv is e to the x dx. Now, since we are to integrate the second function, we can share the integral on both sides. So we have as v equals to same e to the x by the concept of differentiation, having the exponential view. So by the by parts, we have as formula the integral of u dv dx times our dx equals to uv minus the integral of v du dx times our dx. So the left function gives us the original integral. We have the integral of x e to the x dx, u, which is x e to the x, minus our v e to the x, du there, which is 1. So we just have a common multiplication dx. So finally, we have x e to the x minus integrating e to the x by the exponential view generates just e to the x. Now, because of the fact that our integral is infinite, we add the constant of integration as plus k, as you can see.